I want to talk about limits of rational functions, and by that I mean what happens as x gets larger and larger. First, let's look at two really simple examples. F of x equals 10 over x. What happens as x gets larger and larger? Let's start with a number like 1. 10 over 1 would be 10. How about 10? 10 over 10 is 1. 100. 10 over 100, 0.1. How about 1,000? 10 over 1,000 is 0.01. You can see that as x gets larger, that the values of f of x are going to 0. We say, as x goes to infinity, f of x goes to 0. Or we write limit, as x approaches infinity, of f of x equals 0. This is a kind of notation that you'll see a lot in calculus. Let's see what happens to this example. G of x equals 25 over x squared. We'll start again with x equals 1. We get 25 over 1 squared, which is 25. 10. We get 25 over 100, which is 0.25. 100. 100 squared is 10,000. 25 over 10,000 is 0.0025. And you can see that as x is going to infinity, this is going to 0 even faster than the other function. And so here again we say limit, as x approaches infinity, of g of x is 0. Now you can probably gather that this sort of thing is always going to happen when you have a function like this. H of x equals a constant over x to a positive integer power. If that's the kind of function you have, then the limit as x approaches infinity of h of x is always 0. And it turns out that the limit as x approaches negative infinity of h of x is always 0. Those are really important facts, and we're going to use those to find limits of other rational functions